Okay, so this is how you analyze data for the t-test for dependent groups or samples. I have opened PSPP, and this is the usual data view. Because the data are coming from the same individuals, this is the column. The first column here is the number of GRE problems that is solved following self-study. So I entered them in this first column. In the second column, I have entered the the problems that is solved following instructions given to them by the GRE instructor. So this column, the second column, is the number of GRE problems that is solved. So you are going to enter the data side by side because it's the same individual here in this first cell whose performance has gone slightly lower in the second cell when they were instructed by the instructor. So that's how you set it up. First column is for one condition, second column is for the other condition. And as usual, you go to the variable view to define the variables. The first column, I have defined it as self-study. The second column, I have defined it as instructions. That's the performance following instructions on how to do well on the GRE test. The labels, the first one I've labeled as scores following self-study, and the second is scores following instructions. The next thing to look out for is your measure. Here, both variables are scale variables. That is, performance following self-study is a scale variable, and performance following instructions is a scale variable. So that sets up my PSPP for analysis. So to go back to the data view, first column is for how they performed under one condition, and the second column is how they performed under the second condition. The first one being self-study, the second one being following instructions by the GRE instructor. Now I go to analyze the variables. To analyze them, I go analyze, compare means. Again, we are comparing the means in the different conditions, self-study and following instructions. The test that I'm looking for is the paired samples t-test. It's the same as the t-test for dependent groups or samples. So I come here and I select paired samples t-test. And my variables are listed to the left here. I have to move them under the paired samples column, that is test pairs. So I hold down my control key and I select both variables and then I move them. And I click OK. And I go under Windows to see what the output was. I have already run the analysis, so I'm just going to bring it up in PDF format and show you how it came out. So this would be what you will get after analyzing the data. If you go here, you are now getting the descriptive statistics. The scores following self-study were 25.5, that is the mean score, and the mean score following instruction was 19.6. This is exactly what we saw when we did the hand calculation on the PowerPoint. The analysis has now been completed, and as you can see here, this is the precise t-value that we got following the hand computation. It's 6.65. If we go here, it's the same hand computation and we got 6.65. The next thing to look for is what is the significance, and For my analysis, I go all the way to the last column, which is put here. And the significance I get is 0.000. Now remember, this is what you are going to compare to the conventional alpha level. So I have written here 0.0001. And typically when such analyses that are very significant are produced by your software, whether PSPP or SPSS, the last digit is left out by the software. So you have to put it in there, and it's 1. This 0.0001 is far smaller as compared to the conventional alpha level of 0.05, telling you that there is a statistically significant difference between the number of problems that these individuals solved on their own and the number they solved following instructions by their instructor. And as you can see, in terms of the mean scores, when they solved the problems by themselves, they had an average of 25.5. Following the instructions of the instructor and solving the same problems, their average came down somewhat into the region of 19.6, telling you that perhaps they got a bit confused after the instructions they received, so their performance came down. But overall, you can see that their performance was better, significantly better, and this is statistically significant compared to when they were taught how to solve the problems by an instructor. So of the two methods, you would recommend that the students should do it by themselves. Perhaps they, talking among themselves, can get a better understanding compared to what the instructor gives them. Maybe they get a bit confused about that. So that is how you interpret your findings. And as I have said in the slides, let me go back to the slides and highlight something here. When you are doing these kinds of analysis, if you get a negative value, you should always ignore that preceding sign and take the absolute value. So in this case, in the problem that we've looked at, had the results come out as negative 6.65, it wouldn't matter because we would only be looking at the absolute value. Now, the difference between hand calculation and computer calculation or software calculation is that you don't have to look at any chart, any tables in a statistics book to find out whether your analysis was significant. All that is done for you. All you have to be concerned with is to look at your significance. And here in this example, this is the place to look for the significance, and it is 0.000, and you compare that to your conventional alpha level, and as you can see, 0.000 is less than 0.05, meaning there is a statistically significant effect, and that is how you conclude. I will put some assignment on Blackboard for you to work on.